Hello, welcome to On Semiconductors webcast. Today we are going to discuss where and why you might employ a touch sensor switch into your design, some design considerations to keep in mind when implementing them, and some unique ways to implement these solutions. In this webcast, we will introduce to you a touch sensor switch solution for a white goods application. First of all, let's discuss why you would consider using a touch sensor switch over a mechanical switch. This table shows a comparison of several factors you should consider in your design when making a design product selection. A mechanical switch is a device that turns on and off the current flowing along a conductor in end market applications everywhere, such as consumer electronics, TV, STV, and their remotes, white goods, washing machines, refrigerators, microwaves, PC peripherals, printers, fax monitors, automotive instrumental panels, and so on. These switches have historically been the primary design option of many applications. While they have many benefits, they also have many drawbacks, including long-term durability, system noise, responsiveness, and low-speed operation. A touch sensor switch is a type of switch that only has to be touched by an object to operate, such as the fingertips. It is currently used in many lamps and wall switches and white goods, such as refrigerators and rice cookers that have flat exteriors, as well as on public computer terminals. A touch switch allows you to activate the switch by sliding or wheeling, which provides more design flexibility and intuitive user interface than mechanical switches. One benefit to using a mechanical switch is that you physically feel the switch turning on or off by a physical response. When using a touch sensor switch, you can turn on the switch by just touching a screen or input pad. You typically feel no physical response from the switch, and because of this, the user often does not always know he or she has activated the switch. Because of this concern, you may need to equip your switch device with an additional feature, such as light, sound, or another form of physical response to show that the switch has been activated. This will enhance the design element and functionality of the end application and create a more positive user response. A mechanical switch is a simple device. However, mechanical parts are a common source of problems due to a limited lifetime. On the other hand, a touch sensor switch technology has excellent durability and can eliminate mechanical wear and tear. A touch sensor switch does not require a button. This not only cuts down on wear and tear, but also enables the designer the ability to add an exterior layer of material away from electrical components as a protective barrier. Therefore, it is easy to clean, and there is a significantly reduced concern of the switch being exposed to or affected by the elements, including humidity, water, oil, or dirt. Because a touch sensor switch does not require a mechanical switch terminal, it tends to reduce cost, depending on the design. So depending on your design needs, a touch sensor could be an effective and value-added alternative solution. Capacitive sensing is a technology that uses human body capacitance as an input. Capacitive sensors detect anything that is conductive or has a dielectric different than that of air. While capacitive sensing applications can replace mechanical buttons with capacitive alternatives, other technologies such as multi-touch and gesture-based touchscreens are also based on capacitive sensing technology. Now I'd like to introduce to you On Semiconductors LC717A00 capacitive touch sensor. On Semiconductors capacitive touch sensor offers a variety of benefits. Typically, a touch switch costs more than mechanical switches, which discourages many designers from using them. Since a capacitive touch switch does not require external components and offers additional user interface capabilities and improves the user experience, the total system cost may be comparable to mechanical switch in some cases. Just like mechanical switches, our capacitive touch sensor switch is design friendly. It can be connected directly to a familiar MCU and execute standalone operation. Thus, it is very easy to implement, unlike other touch sensors with built-in MCU design to reduce your design time. Now, I would like to show you white goods solution demo replacing mechanical switch with On Semiconductors capacitive touch sensor LC717A00. Today, we chose an ordinary kitchen blender to use in our demonstration to help show the flexibility of design and the ability to implement a similar solution into a variety of end market applications. Multiple mechanical switches are commonly used for this type of application. As you can see, there are 8 buttons on this blender switch panel, and each button is equipped with a mechanical switch circled in yellow. Mechanical switches are attached on the back side of the switch panel. By pressing the buttons on the surface switch panel, it controls the mechanical switches which turn on and off the various functions or speeds of the blender. One of the reasons why a mechanical switching solution is popular is for the safety reasons. There is a perception that since a touch switch solution provides high sensitivity and enables switching activation by the touch of an object, such as the fingertips, many engineers are wrongly concerned that a touch switch would be turned on accidentally by touching the surface of the switching area and cause an unexpected accident to a user. However, an on-semiconductor touch sensor solution overcomes this concern by allowing designers to choose the switch pattern and vary the level of touch responsiveness, thus providing a direct alternative solution to mechanical switches for white goods while optimizing the benefits offered in touch switch applications. While providing the same switching function as used in mechanical switches, you can replace 8 mechanical switches with only one touch switch. As you see here, we replaced 8 mechanical switches with the LC717A00 from On Semiconductor. Depending on your specific design layout, this solution may enable you to reduce component costs as well as board space. In addition, On Semiconductor's touch sensor switch solution is a design-friendly choice. Thus, you can introduce your product to a market even faster. Some end applications require higher sensitivity solutions. As we mentioned, the LC717A00 enables designers to adjust the responsiveness according to their needs. One of the key benefits of implementing a touch sensor switch over a mechanical switch solution is that touch sensors can be located behind sealed air, dust, and water-resistant glass coverings, which is extremely valuable in applications like this blender that deal with the significant potential for interaction with liquid and dust. Unfortunately, some alternate touch sensor solutions have difficulty working effectively behind thick layers of glass or if air gaps are too large between components. Also, touch sensors do not always support high-speed motion and lack in sensitivity, which reduces their other benefits. Through our integrated solution, we can overcome these design challenges and customize I2C and SPI bus control, which realizes high sensitivity, response speed, and noise immunity. Our touch sensor switch solutions provide outstanding clarity and simplicity of design. On Semiconductor, innovative capacitive touch switch technology eliminates design concerns with air gaps and material thickness responsiveness because of our high sensitivity performance, meaning that it enables you to build and implement your design faster. You can still operate touch sensor switch functions through thick materials, significant air gaps, and even while wearing multiple layers of gloves. From a noise perspective, electronic systems with mechanical buttons often have to contain special circuits that improve the noisy input signal. The differential capacity, delta C, between C reference and C drive, and between C and X and C drive is converted to a voltage using the unique technology of a CV conversion amplifier. Unlike other common methods, if similar noises are contained between the two electrodes, the differential detection is less affected by the noise. Thus, differential capacitance detection is strong for noise. We have filed more than 10 patents on our unique automated built-in noise and environmental change compensation function technology, which prevents and compensates for noise-related malfunctions and variations of sensitivity due to environmental changes such as dust or oil buildup, temperature, or humidity. This solution can be used in a variety of applications, including those shown here. It is suitable for white goods, home appliances such as refrigerators, induction cooking, electric scales, drink servers, remote controls, and audio-visual equipment, among other end applications. For more detail regarding the LC717A00 series, please contact your local On Semiconductor sales representative or authorized distributor, or visit us on the web at www.onsemi.com. Thank you.